name's Christina Biggs. I'm a Daphne Jackson Fellow, which is a scheme for getting people back into research after a career break. I've been out for 20 years, and what has brought me back is the increasingly urgent climate crisis. It's led me to develop an idea for producing hydrogen cheaply using the special properties of mud. This is Swansea Bay. Behind me is Swansea University, home of the Energy Safety Research Institute, who specialise in hydrogen. Out there is the Bristol Channel. I've been sailing there over the last 20 years, and the big thing I noticed was that mud is very sticky, there's lots of it, and it's completely free. Hydrogen has been much discussed recently, and it's well known to be the ultimate clean fuel, but the catch is it's expensive to produce. The cleanest way to make hydrogen is by electrolysis, passing electrical current through water to split it into hydrogen and oxygen gas. The most efficient way is to use two flat electrodes close together with a membrane in between, and that membrane has to do two jobs. It's got to pass the current to generate the hydrogen, and it's got to keep the hydrogen and oxygen gases separate. Plastic membranes are expensive, but could mud do the job more cheaply? So why have I chosen mud? Mud looks like chocolate, maybe, but it's actually made of lots and lots of very tiny, flat particles. And these particles do two things. They're dense enough to block gas, which is what we need for this, but they're also highly charged. And I think that with the right treatment, they will conduct electricity, which is what we need for the electrolysis to happen. So this is my mud cell. It's actually built on the same design as cells that use these, which are membranes. They go between the two electrodes, but instead of that, I have a mesh, and where the membrane would be, we have mud. And that is the mud which is behaving like a membrane. So where does the science come into this? Well, there's two things I want from the mud. It's got to flow through properly, and it's got to conduct the electricity to get the hydrogen generated. Mud itself doesn't have a great conductivity, but if we can put a bit of acid in it, then it will be able to conduct electricity that much better. So I can put my mud in, I can measure out how much acid, just start off with a small amount, and there's some bubbling there. What's happening is that the acid reacting with everything else that's in the mud. So this is a scanning electron microscope, and I'm just using it to find out what the elements are in my mud. So I've already done some scans across. I can see it's more or less what I'm expecting for this type of mud. So sodium, aluminium, silicon. But what I'll be doing with my acidification is gradually driving out the ions that I don't want, and just working out, am I managing to flush out ions I don't want, replace it with protons, which will do the conduction of the electricity. So now I've checked that the mud's flowing out, my next step is to connect it to the mud cell, which is the exciting bit. So this is my mud inlet, so I'm going to put it in both sides to make sure it squeezes into the space between the electrodes. I'm going to open the tap and just wait. You see it coming through? So it's filling the space between the electrodes. The mud's now flowing into the electrodes, out through the mesh and out the bottom. And that's what we want, because by doing that the mud's actually squeezing the bubbles of gas outwards through the mesh. So the bubbles then collect here. I can collect the hydrogen from here, but I know that the mud is flowing through, and that will stop gas crossing over the membrane. So, is mud the future of renewable energy? I think we should think about this one. This cell, once you've built it, runs on mud, water, and a source of energy. But it's just going to be a way to store excess renewable energy cheaply as hydrogen, and hydrogen is the cleanest fuel out there. There really is nothing else out there that's portable and completely clean like hydrogen.